Okay, good afternoon. We are now in the Mineral of New York exhibition from the Adirondack Hall, New York State Museum, Albany. About this exhibition, a few weeks ago, probably some of you were attending that virtual tour of the Mineral Collection at the New York State Museum. Now, I'll present you only the specimens that are exhibited, and the people that attended that session couldn't see them. How is it organized? First, we have display cases that show minerals from different geological units and from different regions of New York. For example, we have a display case with minerals from New York City. Probably you won't believe New York City could show us a lot of minerals. Other from central New York, from Adirondack, from Adirondack lowlands, from pegmatites. We have also some that shows different mining districts in New York, and also some groups of minerals, like the amphibole group mineral that we exhibited here. And probably you are the only museum that had a display case only with amphiboles. And I don't want to start showing you the minerals from different regions or from different formations before I'll present you one of the first well-assembled collections of minerals from New York. Is the Orion Root Collection. Orion Root was a professor of chemistry, mineralogy, and geology at Hamilton College, and he conveyed his collections in years to Hamilton College. How the collection got to our museum is very easy, because Hamilton College practically gave us the collection for long-term curation. Is not the minerals that are exhibited here are the best minerals from that collection, but we have another 30-40 boxes in our storage room with minerals from Root Collection. Why it's important, this collection? First, being one of the first assembled collection of minerals of New York, not only of New York but also worldwide collection, there are around 10,000 specimens, and many of these specimens are from locations that are completely depleted at this moment or are abandoned. And some of the specimens are unique for modern mineralogical research. And from here, I can show you some that are very important, and I can tell you the story of this mineral. First, look at this mineral here that is called spinel. It's a magnesium aluminum oxide. And the locality is Monroe. What is important for this one? It was 1840, on two people from southern part of New York, Horton and Jenkins, started to collect minerals. And they found the location where they found these minerals. Because they didn't want anybody to know where the location is, they started to mine these amphiboles, these spinels, only under the moonlight. They collected it, and they, in I think 1853, at Crystal Palace exhibition in New York City, they presented this giant, at that moment they were giant spinels, and their value was at that moment around $6,000. That was a very big treasure. The only problem with this, we couldn't find the exact site of them, because they didn't want anybody to know where these were from. We know it is somewhere between Monroe and Southfield. We checked for years this location, or ages, or creeks, and everything there, but couldn't find them. But we were able to do some forensic mineralogy in the lab, looking a little bit at the minerals that accompany these spinels. Why? To see if we can find at least a restricted region where they could be collected from in the old times. And they looked at the amphiboles. We know after our studies that the amphiboles that occur in Franklin marble are sodium and fluorine-rich amphiboles, and the others that are collected from iron deposits in the Hudson Highlands, the Grenville part of southern New York, they are potassium and chlorine-rich amphiboles. Now, the amphiboles that accompany these spinels are chlorine-rich amphiboles, potassium-rich amphiboles. But again, this is only a clue that we have, but we couldn't find it. Another stuff I want to present you, look in the back there by the prismatic quartz. On the right is the mineral that is called millerite. There are some spectacular, very tiny, acicular, shiny yellow crystals, which is millerite, is a nickel sulfide. Why it's important? Because from this Sterling mine, Antwerp, Jefferson County, millerite was the first one found in the United States. It's the first location with millerite in the United States. Also, other interesting and important minerals that are in this collection are this galena from Rassi. Why? Because New York doesn't have lead deposit. Rassi, even it was a very tiny point on the New York State map, it had a vein with large calcite and beautiful galena crystals from there. Also, the fluoride on the left side of this is the Macomb fluoride. Practically what we can see here is from the old times, and some of them are unique specimens. Now, we think we can move toward the southern New York, and we'll go to New York City. I know New York City is well known by its skyscrapers, and everybody can say how it was possible to find these beautiful minerals that are exhibited here. They are or from the foundation when they build the skyscrapers, or when they build the subway system there. And many of these specimens here belong to the New York City Mineral Club that gave us, and they are for the first time exhibited in a museum. And this is important because New York City Mineral Club is the first and the oldest mineral club with continuous activity in the United States. What are the most interesting minerals from there are this chrysoberyl, beryllium oxide from here. There are also some calcites there, or this beautiful green talc, some feldspars that you see in that cold, and also some garnet. It's not the subway garnet that is very well known in the American Museum of Natural History in New York City, but they are nice for a region that is extremely populated, is completely paved, and it is practically there are only some parts with trees, and that's it. But the minerals are still there. And new construction for water tunnels and so on can bring us more minerals from underneath New York City. Now we can move here. It is we call gems of New York. They are not real gems because they are not diamonds, they are not sapphires, but there are minerals that can be cut, polished, faceted, and make very beautiful the so-called gems. You can see that calcite. See, the calcite could be a very nice gem. It is from Balmat mining district. That was another one, which is very interesting. Here, it is that labradorite that shows a little bit these iridescent colors. See, when you move there, it's very nice. The fluorite, different colors of fluorite, green to this fluorite. Then we have this sphalerite from a Hyatt mine. It is from St. Lawrence County. Even quartz could be polished, faceted, and transformed into a gem. Serpentine, the same, and many other minerals that are in the ground of New York State. from different locations. A little bit further, we'll move to some locations going towards central New York. Lockport Formation. Lockport Formation, it is a Silurian formation that extends not only from central New York till Niagara, but also goes to Canada. And there are some interesting cavities that are filled with minerals, with dolomite, with calcite, with gypsum, with fluorite. Sometimes the fluorite showing very interesting colors from yellow to practically violet there, with sphalerite, and so the problem with this formation here is very interesting, because a lot of people said, where are these elements that came with mineralized fluids to bring this mineral in the this formation is interesting because it is formed initially in a shallow sea, an inland sea, and because of the climatic condition and the morphology changing, it became a hypersaline, and a lot of halite and gypsum precipitated from fluids and formed in this formation. Another formation also is the Little Falls dolostone. Why is so interesting this formation? Everybody heard about Herkimer diamonds. They are not real diamonds. They are quartz crystals. But because they are short in c-axis, because they are flawless, and they look like diamonds in some aspects. Normally, they are not only in New York, these Herkimer diamonds. They are found also in Arizona. They are found in Afghanistan, in Ukraine, in many other places. But normally, they can't be called Herkimer. And they are called Herkimer because of the county when they found. Sometimes they are called Middleville diamonds that are exactly the Herkimer, the Little Fall diamonds, and so that Herkimer diamonds is a generic name for all the location in New York that have these minerals. A little bit further, we'll go now toward another beautiful part of our state is the Adirondack Lowlands. Adirondack, you know, it's one of the iconic regions of New York State. And it is divided geologically into two domains. One is the Adirondack Highlands, and the other one is Adirondack Lowlands. Between them, it's a very large and very well-known deformation zone called the Carthage-Colton Milonite zone. And the geology and the degree of metamorphism is metamorphic grade is different. Granulite in facies in the Adirondack Highlands, and in the lowlands is amphibolite facies. But because of the combination of the geological ground, like marbles, granite, gneiss in the Adirondack Lowlands, metamorphism and the fluid, a lot of beautiful minerals came from this location. And here we'll go again to this Rassi we presented in root collection with not only with galena, but also with beautiful pink calcite that came from that location. We talk about millerite. You see this greenish mineral here. It's picorite, which is a nickel silicate that is a secondary mineral formed by alteration of a millerite, and a lot of scapolites. You can see apatite, very nice apatite. Some beautiful titanite and this green diopside from Pitcairn, from Rose Road location, or in that corner there, it is a diopside, a gem diopside from St. Lawrence County. Also millerite, you can see again that millerite, and a large zircon crystal there, which is from Beck collection, Beck being the first mineralogist that did a mineralogy review of New York State. He went all over the locations that are known in 1837 and collected minerals, and part of them are in our collection, part are in Rutgers University collection. Now we'll go a little bit to changing the case, and we have also a recent acquisition case. That means if we get collections or get specimens from people in 1 year, we put them in this cabinet. Now, because we have a big donor, Dr. Steve Chamberlain from around Syracuse, from central New York, and he gave us a lot of his specimens from the collection, we did this display case with mineral from the Balmat Edwards Mining District. It is also a book written about this one, that this is the cover of the book, and some of the specimens that it was part of the last donation from Dr. Chamberlain, it is in this display case. And what is very interesting here is this magnetite. One of the most important stuff is this magnetite. Why this magnetite is important? Because it's a cubic magnetite. Generally, magnetite doesn't crystallize in this form. And there are also other deposits in the world that have magnetite, cubic magnetite, but the crystals are small. These are the biggest one ever found. And normally, they are not at this moment easy to collect because the mine, that part of the mine is closed. But we are able to gather from many donors, and or by donation or by purchasing, to have most important of these minerals here. And these cubic magnetites are accompanied with this, they call bird eye sphalerite. It's not a real bird's eye texture, but it's very interesting, and it is interpreted at this moment as an alteration zone toward the surface. Yes, that one. Then next to it is this tremolite or hexagonite. The mineral is tremolite. It's called hexagonite because when it was found, they said it's a new mineral, and it was described as a new mineral for 1 month. After this, they realized it is tremolite. The laterite from Balmat number 4 mine is also present here, and many other minerals are in this cabinet. But let's go now to one of the mineral group that I like very much, the amphiboles. And here is the amphibole group of minerals. And look at this one, richterite, that it is collected from Balmat mine. It's not asbestos. Don't be worried about this. It's not asbestos. There are only acicular mineral crystals there. But what was very interesting was how the miners were able to bring it on the surface from the underground in Balmat without destroying it. The minerals here are with different composition. Mostly are from a tremolite group. Other are edenites, pargasite, and you see the green one here. The green one is because it contains tiny amounts of chromium, but it's also a tremolite. And the pink one, that is again the hexagonite, and the color is given by the tiny manganese that is in this composition. A little bit that tremolite is a little bit chromium also from Mulvaney property that appears. And going now toward the Franklin marble. Franklin marble is well known more in Franklin, in New Jersey, where these deposits at Sterling and Franklin are well known by their fluorescent minerals. It's so interesting, and even the dump there is full of fluorescent minerals, and there are some days in which you can go there and collect and look at the minerals. But we have also Franklin marble here in New York, a little meat. But it was important because a few minerals that were found for the first time in for the first time they were described for science were from Franklin marble in New York. It is this clintonite, which is a mica that appeared there. It is the warwickite that is also from the type locality. All these are from type locality. Another mineral is fluoropargasite that is collected from here. Yes, fluoropargasite that is also on the minerals that appear from here. That the first time they were described from this formation in New York. Don't think there are no pegmatites in New York. Probably they are not so spectacular like the pegmatites from California, from Maine, or from Brazil, but we have pegmatites here, and some of the minerals are very nice. Let's start with this first part, this microcline that we call Amazonite, that is from around White Plains, and it was 1915 when people wanted to build the Kensico Dam in White Plains, and they needed rocks, and they started to dig around, and they found a vein with Amazonite, and from this vein of Amazonite we were able to collect to have in our collection a lot of mineral, and here it's only one specimen. Another one is this Day or Atlas Quarry that is in Saratoga County, where this very nice tourmaline, very big tourmalines were collected from. Look at this molybdenite. Not very easy. You can see it is what we call the pegnacoid, that is the basal part of the hexagonal prism. It is the molybdenite that is from a small pegmatite at Star Lake. At Star Lake, it is one of the biggest open pit for iron ore, and in some pegmatites this molybdenite was found. The zircon crystals also from Rassi. We look at this Rassi, very interesting. It's a very interesting location. Normally at this moment you can go there and collect minerals, of course with permission from the owner of the property, but they are not the same quality as they were more than 100 years ago when they collected the specimens we have now in our collection. Another very interesting, and I think not very common, is this aluminum silicate, the Sillimanite. Look how big it is, that Sillimanite here. It is almost 20 centimeters from one end to another one. It's also from the Star Lake, from pegmatite, cutting the iron ore and the host rocks. Above we have the columbite from Bedford, group of pegmatites. And what is interesting with this pegmatite, we were able to date these pegmatites. We were able to determine the age of this pegmatite using the uranium lead columbite dating. How do we know it is correct, the date? We analyzed in the same time also some zircon from these pegmatites when we got the same age. It is Neo-Akkadian, that is around 380 million years before. Now we'll go to Hudson Highlands. See, we have another one of the giant spinels from Monroe. They are not spectacular at this moment. If you are looking on the web or going to Burma or another part of the Southeast Asia, you can find very beautiful glassy spinels, colored red and so on and so on. But remember, these were the first found ever giant spinel in the world, and this moment they practically made the exhibition in New York one of the best. We have also some specimens from Brewster. It's written here. From Brewster, Putnam County. It is the Tilly Foster iron mine where they are collected. Tilly Foster iron mine, it is well known for 98 valid species collected from them. Some of them beautiful, like the chondrodite we have here on the left, the clinochlore, the magnetite, the brucite, the serpentine, very nice stuff. It was found in 1810, I think, and it was worked for a long time until 1895, when they had a big accident there, when around 100 tons of rocks killed 13 miners, and they were practically they had to close the mine in 1897. But the minerals that were taken from there are beautiful, and they made the best part of many, not only private, many are in the private collection for sure, but not only the private collection but also the museum collections. Other minerals very interesting there are these Hedenbergites from Iona Island that appear there, or this potassic pergasite also from Monroe, which is very interesting. The brucite I told you about, you have there the greenish stuff with a micaceous aspect. We have another display case with minerals that are from different locations. Practically this location don't have enough minerals to make a display case only with them. Then we put a display case with, which is the case of this Celestine from Chenango Falls, or this goethite, very nice stalactite goethite from Dutchess County, quartz, pyrite, calcite, and prehnite from different parts of New York. Some look at this rutile from Ossining in Westchester County. That is a nice one. Or this quartz from Kingston, Alabama. You have also this nice pyrite in this part, which is probably a lot of people will know that is fossilized and pyritized poop from the Devonian fish that is now very, it's Alden in Erie County found. Now we can go to, again, to, we had in the display case there at recent acquisition, we have now the minerals from the Balmat Edwards mining district here. You have on the left, on the right, find here, we have the distribution of the ore bodies in the rocks, there. On the left you have the geology on the region, and on all these display cases we have the best minerals from that mining district. Starting with the blue stuff, that is the lasurite, that or lapis lazuli, you want to call them, with some gypsum, with some barite, celestine, and some calcite, with this beautiful diopside, that is blue diopside, and the pink tremolite, with these gemmy sphalerite crystals, with hexagonite, with this beautiful tark, with chrome tremolite, with bird's eye texture, beautiful halite and selenite stuff that we find there, with rhodonite and canoite, which is a pyroxene. Why this is important, the Balmat Edwards? First, one of the minerals that is the first time described, dompicorite, is from Balmat, and it also tornorite, which is the co-type locality for that mineral, Balmat. The cubic magnetite again is there. The phlogopite mica, that is a very strange color for a phlogopite that we have here. And I don't think we finished with our collection. We go a little bit to see the large specimens that are exhibited here. Even it is a small area, we had space to put almost all the specimens we wanted to put. Here is the pyrite from Pierpont mine. It is this beautiful bright green fluorite from Star Lake, and also this pink calcite from Balmat, the travertine from Litchfield, the celestine and calcite from Chenango Falls, the pyrite from Nedrow, that oovite from Bauer Power's farm, this fluorite from Woolworths, New York. Again, this beautiful fluorite, large fluorite crystal from Macomb in St. Lawrence County, the halite from Livingston County, large specimens here of chalcopyrite and quartz from Allenville, that in Ulster County, towards southern New York, the actinolite from Russell, and again the calcite from Sterling Bush mine. Sterling Bush mine, it's not a mine, practically it was they said cave. It was a void, only not more than 6 meters long, that in 1906, the blast they found it, and it was practically lined with very large and beautiful crystals. There were around 18 tons of calcite crystals that were excavated from there, and one of them was more than 500 kilograms. That it was a huge one. We have around 200 crystals in our collection. Most of them are in Rotterdam when we have the storage, and some of them are here in New York and Albany, New York. And now, because we are toward our trips through the collection, I would like to show you the minerals from the fluorescent minerals of New York. We have a nice display with fluorescent minerals that are only from New York, not from other parts. It is here, and they are by name. And you have first, when we push the button, 15 seconds for long wave. Then we have 15 for short wave, and then another 15 for all for both long and short wave. Let's start to see, and let me know which one you like more, the short, the long, or both of them. Then we have to count till 15 until the long wave. Now it's short wave. The mineral seems to be a little bit more attractive at this moment, and soon we'll have much better view of these minerals, like now when we have all of them. We have too much light here because some of them are glowing in the dark after the UV light started to stop, practically ignited them. Done. We are done. And I think, I don't know if I missed, I think probably I missed one of the, no, I didn't. Yes, I missed one. I missed only the Adirondack Highlands, which is one of the most interesting part of the state. Hey, look here, Adirondack Highlands. Adirondack Highlands, it is part of this orogen, that is the Grenville orogen. You see there, of course, this is only for North America, but it is also in Scandinavia, it's also in Canada, and then going down to, yes, this is the short description I have. The Adirondack Highlands has in the middle a very nice and large anorthosite, and the rest are metasedimentary rocks and gabbros and granites that are intruding in metasedimentary rocks. And the granulate facies with reaction between different intrusions at the metal sedimentary rock and the fluids that accompany them sometimes practically gave rise to these minerals. It is that the serendipite that is there, which is one of the blue stuff, that is one of the, in that corner, that's serendipite. Yeah. Then we have this fluorite again from Star Lake, the beryl from the Bachelorville, one of the pegmatites from there, the microcline that has inclusion of hematite that gives this color of the calcite from Lion Mountain, the garnet from North River, Warren County, which is one of the most well-known garnet deposit in the world. There were garnet there that had more than 1 meter in diameter, and of course probably somebody had them. We don't have, we have only one like a soccer ball in our collection, but there were also. And look at this magnetite from Mineville, which is very interesting how it looks like. And another one, also a very smoky quartz from the Star Lake. And I think with this we finished our trip through the mineral collection and mineral exhibition here at Albany. Thank you for attending this not very long, not very short, but I think not boring at all presentation of what we have here at New York State Museum in Albany. Thank you.